Students, this is lesson 7.6, circles, circumference, and area. Don't forget the date, time, location, as well as a parent or guardian sign-off. These three review problems, I want you to do them completely on your own in the next couple minutes. Restart the video with a red pen in hand. Welcome back. Let's see how you did. With a red pen in hand, we have x minus h, parentheses squared, y minus k, parentheses squared equals radius squared. Our h, therefore, is 0. Our k is -1, and our radius is 4. So you start graphing 0 and -1. And then we bunny hop. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And hopefully your circle is a little bit more circle-ish than mine. This is an inscribed angle, half the arc, so it's half of 180, which of course is 90 degrees. This is a tan-tan. That's going to be angle equals big arc minus little arc over 2. Big arc minus little arc over 2. So big arc, we are missing minus little arc 117, but you can see right now to get that big arc, you simply subtract the 117. And of course, you get 243. So we have 243 minus 117 over 2. (126) divided by 2, that's going to be 63 degrees. All right. Today is one of the most far-reaching lessons we're going to encounter, meaning the material you're going to see right now will impact several future math classes, as well as future science classes like physics and geology, even oceanography, as well as future PSAT and ACT and SAT testing scenarios. Again, we're talking about a circle, radius, diameter. You're familiar with those words, new words, circumference, area, and pi. When I say pi, I do not mean cherry pie. I mean the Greek letter pi. In the following circle, we're going to trace the circumference of the circle and trace the diameter. So let's trace the circumference. I want you to trace it all the way around. Circumference, and then trace the diameter. Do the same thing here. Trace the circumference and trace the diameter. Last one, let's do it again. Trace the circumference, trace the diameter. All circles have the same shape, but a different size. Same shape, different size. That should ring a bell here, folks. Same shape, but a different size. And that defines the concept of similarity. Similarity. Now, when things are similar, they have these properties. Similarity is congruent, angles, ratios, equal. This is what we're going to focus on today. Similarity. Because circles are similar, the ratios of some key components, and we're going to look specifically at the ratio of the circumference divided by the diameter. ratio regardless of the circle's size. That's really important you understand that regardless of its size, that there's a certain ratio that's the same for all circles. And it's the same because all circles are similar. There's a very special ratio in which you divide the circumference by the diameter. And since all circles are similar, this ratio will be equal for all circles, regardless of the shape. Let's talk about that. So we know that regardless of the shape, there is a certain ratio that is calculated by dividing the circumference of a circle, which is going around. That's why we're drawing a line. The circumference divided by the diameter. Notice I use a capital C, and that is because it's wrapped around two dimensions. Although technically circumference rolls out to one dimension, which is just length. But because it's wrapped around two, normally we capitalize it. That ratio of the circumference divided by the diameter is constant for all circles, regardless of the size. And that ratio we call pi. You commonly know it as the decimal version 3.14. So, if we were to isolate the circumference, or get the circumference by itself, you're going to get a functional form that you're going to see very often. So we're going to multiply both sides by the diameter, and you get this very important equation. To find the circumference of any circle, you simply take the diameter and you times it by pi. So circumference is two versions equals d times the constant pi. Now, because the diameter has two radii, when you take SATs and PSATs, they're going to do it like this. Instead of the diameter, they're going to say 2 radii, and they stick the pi in the middle. 2 pi r. They're exactly equivalent, but I will never use the one on the right. I will strictly use this one on the left. Why? Because the one on the right gets confused with the area equation. So I personally will always use circumference equals diameter pi. Now to find area, I'd like you to simply shade the area. Shade it. To find the area of a circle, you take the radius and square it, only the radius, times by the constant pi, or pi r squared. Realize that r squared only goes with the radius. That's why I stick parentheses around it, because it only goes with the radius being squared. It is not this. Do this right here in the margin. Go like this, say pi r parentheses squared, write that out. And then I'd like you to cross it out. You will never use that. That is incorrect. You only square the radius when you're working with the area of a circle. Now, to help you remember these, we have a little jingle, probably one of the most infamous and famous of the entire year, even more famous than the 30, 60, 90. You want to start a flash mob at a rally with a geometry jingle? This is the one you start with. And heads up, students, you come with a great jingle, you'll go down in infamy, because I stole this from a couple students, modified it from their idea. Thank you, Courtney, Laura, and Megan, year 2007. So let's write out what the equations are. Circumference equals diameter times pi. And area equals pi times the radius squared. Just write those two equations out. Ready? It goes like this. C d pi, I c d pi. D pi, I c d pi. Apple pie is really, really good. Apple pie is really, really d pi, I c d pi. C d pi, I c d pi. Apple pie is really, really good. Apple pie is really, really good. C d pi, I c d pi. Apple pie is really, really good. You visualize it like that. R times R. Really, really good. Apple pie is really, really good. Let's pull this together, folks. All right, so I'm going to show you how to use your calculators here. So at some point in your calculator, most of you have a pi symbol. Okay, on the regular 30 calculators, you look for the pi symbol, and when you press it, you'll get the equivalent of pi with your 3.14 with a bunch of decimals. On some calculators, you have to hit the second function to get the pi sign. So take a moment and figure out how to get the pi sign on your calculator. If you need to, pause the video, figure out how to do that. Ready? We're given the diameter. You're going to find the circumference and area for the following circles. Express your answer in pi form. You leave the symbol in your answer, and without pi, decimal form. There's another way we describe these. Pi form is also called exact. Exact. And decimal form is called approximate. Exact. So if you see in the SAT or PSAT or ACT, it wants the exact form of a circle's circumference or area. It's going to be with pi in your answer. You'll see what that looks like in a moment. And if it says an approximate form, it's the decimal version, and it'll usually tell you what decimal to round by. Ready? This is easier than you think it is. Step 1. Physically trace every time. Diameter, trace it. It is 10 meters. Radius, trace it. It is 5 meters, which means your radius squared is 25 meters squared. Now, to write the circumference, write your equation. C equals d pi. Area equals pi r squared. So for this one, our circumference is going to equal diameter, which is 10 pi meters. You're done. That, my friends, is called exact pi form. It is the preferred form in the vast majority of future math and science classes. That's called exact pi form. Your area, pi r squared. We already have the r squared, so our area is going to be 25 pi meters squared. You're done. The decimal version. I'm going to use now the approximation sign because the decimal version is an approximation, and you're going to round it to the hundredths place. So for circumference, we're going to go 10 times, and then find your pi key, hit the equal sign, round it to the tenths place, 31.41. So this is going to be approximately 31.41 meters. And for this one, it's going to be 25 times the pi key equals 78.54. 78.54 meters squared. Ready? Let's come up here. Our diameter, physically trace it, is 16 meters. Radius, 8 meters. Radius squared, 64 meters squared. C equals d pi. So our circumference for this is C equals 16 pi meters, which is approximately 16 times pi. Please do that on your own calculator so you know how to use it. 50.27. Our area is going to be pi r squared. We already have our r squared, 64 pi meters squared. This is called the exact pi form. Again, that's the preferred form in future math classes. Just because it has a Greek letter in it doesn't make it weird. It's the preferred exact form. So this time we go 64 times pi, 201.06, approximately 201.06. Watch your units. This is meters squared. Again, last one. Trace the diameter. C equals d pi. So we simply go 6 pi meters. Your little approximation sign, get out your calculators. Approximately 18.85 meters. Our area, of course, would be 9 pi meters squared, approximately. .27. meters squared because area is 2 dimensions. Once again, so pi form is called exact, and decimal is the approximation. Let's go through a few examples together. It says the circumference of a circle is 18 pi. What is the area? So step 1, trace what you know to be true. Circumference is 18 pi centimeters. What is the area? Take a moment and always shade when you're talking about area. It helps your brain register. Let's write your equation out for area. Equals pi r squared. Notice I put parentheses around my radius. Write both equations. Start with what you have. C d pi. I c d pi. C d pi. I c d pi. So take a close look here, folks. Circle it. We just figured out by writing down the equation that our diameter in this circumstance is 18 centimeters. And if our diameter is 18, our radius is 9. So now we take that 9 and plug it in right there. Bring down your equation. And the area equals 9 squared, which is going to be 81 pi centimeters squared. And that, my friends, is your final answer unless you are required to get the decimal to do something else with it. But if I don't specify, you're welcome to leave it in pi form. Now, warning, if you were to try to write this equation like this, see what I just did? My friends, that would be incorrect. You cannot randomly just take out the pi. The correct answer here for the area is 81 pi centimeters squared. Let's try another one. The area, underline that word, of a circle is 200 pi meters squared. Right by is, put an equal sign. What is that circumference? Start by writing your equations. Area equals pi r squared. Circumference equals d pi. We want the circumference. That's what we're going for. A little question mark. So trace it. We've been given the area. So ready, circle the area right underneath is 200 pi meters squared. Notice how the area is repeated, which means that's now equivalent. We're going to solve for the radius. So we're simply going to divide by pi. You can do that. You need to realize pi is a number, folks. It's a very special number, but that pi is an actual number. You treat it just like you would any other number. That cancels, that cancels. So we now have the radius squared equals 200. So we can square root. You ask yourself, what is the square root of 200? You can factor. Okay, so I'm going to pull out, I already see my doubles is going to be 10. So my radius is going to equal, let's just draw it in here. It's going to be 10 on the outside, root 2. Okay, so let's now go over here. And for circumference, we want the diameter. So drag it all the way across, and we're like, but wait, it's twice the length. Let's write that down. 2 times 10 root 2. It's not cooperating. Only the outies talk to each other. So the 2 and the 10. So we have now figured out that my diameter is 20 root 2. So to find the circumference, we come over here, we plug it in. So our diameter gets plugged in with 20 root 2. Your complete answer, you have pi. You check for units, that's going to be 1 dimension meters, not meters squared. Circumference is only 1 dimension. So your complete answer for the circumference is 20 root 2 pi meters. Now we're going to get into some practical examples. If a wheel has 24 inches in diameter, how many revolutions will it take to travel 100 feet? We highlight, draw, label, list, cross out. Let's put the information that we know is true. First, we know our diameter is 24 inches, so let's just draw that in. D equals 24 inches. We took care of that. We're asking how many revolutions. Now, when you revolve a wheel, it turns. Go like that. It turns. It turns. So what you need to see here is that when a wheel revolves, the word revolution is simply code for circumference. Revolution is code for circumference. Let's write our circumference equation out while we're at it. We're asking how many revolutions will it take to travel 100 feet? So if you were to take this wheel, every time it turns, it will travel a certain distance. And we're asking for every turn, how many turns will it take to go 100 feet? Now, we already established that the word revolution means circumference. So what we're actually asking here is how many circumferences will fit into 100 feet. Let's take our equation here. E equals d pi. E equals 24 inches pi. Now, because I'm going to use it to do something else, I'm going to get the decimal version of this. To your calculator, make sure you're getting the same thing I am. Take it to the second decimal, which will be 75.398, so that's going to turn to a 4, 75.4. Now we're going to use the approximate sign because that's an approximation. Careful there, mark your units. Your units, every time that wheel turns, it's going to travel 75.4 inches. But our distance is in feet. So before you crunch those numbers with the 75.4 going into 100, you convert before you crunch. So we're going to take this into inches. We're going to times it by 12. So 100 feet becomes 1,200 inches. And I'm asking how many circumferences or revolutions go into that. So we're going to divide by our circumference, which is also in inches. Notice our units are now aligned. Get your calculators out. We're traveling 1,200 inches. We're dividing by the circumference, which is revolution. And we see we get approximately 15.91 revolutions. And you do a problem like this on Alex, it's going to want it in whole revolution, so you can take it to approximately 16 revolutions. All right, these two I want you to do on your own, folks. All righty, students, you should have done this on your own, and now you're just checking your work. We have here the area of this circle is 64 pi meters squared. That means our r squared should have equaled 64. Your radius is 8. Circumference equals d pi. Therefore, your diameter, if your radius is 8, your diameter is 16. The answer here is 16 pi meters. 16 pi meters. Down here, it said the circumference of the circle going around is 36 pi centimeters. C equals d pi. My diameter is 36, which means my radius is half of that, which is 18. So we come over here, area equals pi r squared. So 18 squared. Let's try that again. 18 squared. 324. So you should have gotten for your area is 324 pi, check units, centimeters squared. Using a red pen, I expect you to correct your work. If you are correct, giant smiley face. If you were not correct, or if you missed something simple like units, folks, make yourself a little note about what to remember next time.